In this video, we'll be making a gable wall and some roof structures to the sample house that comes with ArchiFrame. I removed the gable wall and some rafters so that we could begin like this. ArchiFrame can be found from the options menu. I use the default data template that I copied from data_yours_base_own to begin my work with the model. Here are the settings in ArchiFrame. Please see the video link in the description for details on how to set up your own environment. Making the wall. Before going on, let's see how the building looks from the architect's perspective. Here, the wall is split into multiple pieces and the wall levels do not matter since ArchiFrame will select the correct geometry from all the related walls. So let's start by doing the gable wall first. Switch to a layer combination that shows ArchiFrame elements as solid layers and the architect stuff as wireframes. Then let's add the gable wall on the floor plan. Open the element tool, select the structure to use. Then let's have a look at the settings for the core layer. One important setting is the spacing between the studs. And here we can also define the main material to use in framing. Let's use this composite type. Force the bottom level of this wall to -60 relative to the active story. Let's look at the settings here. Here is the insertion line of the core interior side. From the wall settings, we will lower the roofs by 173 millimeters, and elevations are created into the current story. Using these settings, let's add the new element by drawing a line. I will start by drawing it from the upper corner going counterclockwise. I could end the element anywhere, but in this case, we'll make the wall as a single piece, producing a single drawing. Next, give the wall a unique ID. This way all pieces in the model will have a unique ID themselves. Then set the corner type to be compatible with the existing walls. Before creating the planks, let's see what we have in 3D. We lowered the roofs by 173 millimeters, and that is the height of this existing piece. Then, let's apply layer offsets using a predefined preset to get the cladding and the related open ventilation gap to extend lower, and the interior to start higher than the core layer. And the same for the openings. This way we'll have space for the weatherboards. Now, let's create the framing. The result in 3D, in the floor plan, you have full control of everything, so you can, for example, delete this piece. Then the element elevation, which is the most important part of the wall documentation. The rules we use produce these dimension lines, and the weight and center of gravity is calculated with and without windows. Projection of all the layers from above, cut list and then projections of each construction layer, windshield boards and cladding. Then from looking inside, there's the insulation and additional interior studding, and the interior gypsum boards. Now that the automation has done its work, it is time for the designer to complete the structure. Let's use the Element Options tool to add a double bottom plate. We have a remark here indicating that the maximum length of the raw material has been exceeded. The easiest way to get rid of that is to use the automatic cut top and bottom feature that also correctly overlaps the cuts. Then, if you had a CNC machine, you could also add marking grooves to specify stud positions. Then, let's add lintels or headers for these openings. Can be found under horizontal structures as well. Select the beam material and join the beams if closer than this value. There's a small gap between the studs generated by minimum distance setting in the editable framing rules. The result in 3D, there's a connection between the beams and the groove studs. The groove will be removed from the stud if the beam is removed. End results. Then let's prepare the model for CNC output. Let's begin with the cladding. The first step is to explode it into separate pieces. After doing that, you can edit each individual piece as needed in the element drawing, 3D or ArchiCAD section, or even elevation. ArchiFrame keeps the element drawing and 3D models in sync. Let's add nailings to be done by a framing station using a predefined preset. To do that, we should select the cladding pieces and the nailed target layer with the ventilation gap layer behind. With this preset, we get nails 20 millimeters from the bottom and 30 millimeters from the top of the cladding piece, like this, in 2D as well. Then let's add nailings to the boards. Again, use a preset changing the spacing at the board edge to 100 millimeters. Cladding nailing should be added first, since ArchiFrame will avoid having two nailings in the same position. The latter one will be moved if needed. A framing station can also cut the cladding and boarding. Remove the bottom saw cut, then add the saw cut to the windshield boards. Before producing the end results, we need to update the element drawing. It will calculate the weight and center of gravity, assign the same ID for similar planks, update dimension lines, and cut lists as well. For manual cutting, you can generate dimension drawings with this tool. Using this detailed drawing instruction, you could accurately cut every single piece. Then let's produce more end results using this palette. First, let's write a summary list corresponding to the selection. It looks something like this. It has one type per line. Then the default quantities listing, it puts one similar plank per line. Because of the gable wall, we have quite a few lines of different lengths here. Then the estimation of how long making the wall will take based on these criteria. You can also make your own ArchiCAD schedules. Then let's generate some CNC for a cut saw from the main framing. First, let's look at a Hundager BIMx file using these settings. In Hundager Cambium, our file looks like this. Each separate part looks like this and will have its own ID. Another cut saw example is the widely used standard BTL file format. The result with the free BTL viewer is here. BTL is also good for writing a framing station file. And finally, the CNC output for a Refinements framing station using the WUP file format. Here we have the cladding pieces and related point nailings. First, we hide this layer to see the ventilation gaps underneath. Under the ventilation gaps, we have the marking layer showing every fourth cladding piece and the ventilation gaps as well. And the windshield boards with their nailings. And then, of course, the main framing that the framing station puts together. Then, last but not least, paperwork. Let's create layouts using ArchiFrame. With these settings, we got these results. The main framing layout on its own sheet, and two other sheets as well. And the dimension drawings as the last one. With ArchiCAD tools, you could create a publishing set generating all PDFs and drawings with a single click. You could also publish this as a BIMx model. Please see the video link in the description to find out more.